Hello, everybody. My name is Andy Garza, and my partner's name is Viviana Soto. So, without further ado, the topic for our group project is going to consist of the humoral immunity. So, going in chapter 7, what are the phases and types of humoral immune responses? So, there are various stages to the humoral immune response, including recognition, activation, effector, and resolution. During these stages, the immune system creates memory B cells, expands its clonal population, and makes antibodies, which enable the body to mount a primary and secondary defense against infections. As for stimulation of B lymphocytes by antigens trigger B cells in humoral immunity by binding to their surface immunoglobulin receptors, otherwise known as BCRs. More so, an efficient immune response is started when this identification activates B cells when, which then proliferate, differentiate into plasma cells, and produce particular antibodies against the antigen. As for antigens, we have several different types, one of them being T-dependent antigens and T-independent antigens. As for T-dependent antigens, T helper cells are necessary for T-dependent antigens in humoral immunity to stimulate B cells and cause their generation of antibodies. This relationship provides a strong and efficient humoral defense, especially against protein antigens or complex infections. As for T-independent antigens, through repeating epitopes or molecular patterns, T-independent antigens in humoral immunity can directly activate B cells without the aid of T helper cells. Through the generation of antibodies via this route is not as strong or varied as it is with T-dependent antigens. So, what is the role of innate immune signals in B cell activation? Through pattern recognition receptors, innate immunological signals play a critical role in the first detection of pathogens during humoral immunity, which in turn activates B cells. By stimulating B cells to proliferate, differentiate into plasma cells, and produce antibodies against the invasive pathogens, these signals aid in the initiation of the adaptive immune response. As for heavy chain isotope class switching, B cells can produce several classes of antibodies, such as IgG, IgA, or IgE, while retaining antigen specificity in humoral immunity. Through this procedure, the functional features of the antibody are tailored to unique needs of various pathogens or immunological activities, enhancing the efficiency of the immune response. As for affinity maturation, B cells go through repeated rounds of selection and maturation to create antibodies that have a higher binding affinity for particular antigens. Over time, this improvement in antibody specificity increases the immune response capacity to target and neutralize infections. As for regulation of humoral immune responses, otherwise known as antibody feedback, in antibody feedback regulates the activity of B cells and antibody production through mechanisms such as negative feedback loops. When antibody levels rise, they can inhibit further B cell activation, maintaining a balance in the immune response and preventing excessive antibody production. Moving on to chapter 8, we have effector mechanisms of humoral immunity. So, effector functions of antibodies. Antibodies have effector activities that include attaching to pathogens and neutralizing them, blocking their entry into host cells, and designating pathogens for immune cell destruction via complement activation or opsonization. Both removal of illnesses from the body and the development of immunity against new infections are aided by these processes. As for vaccines, vaccines operate as an effector mechanism of humoral immunity, stimulating the generation of antibodies by activating B cells. These antibodies provide protection against disease by quickly neutralizing or eliminating the invasive bacterium upon subsequent exposure to the related pathogen. So, this then concludes the group project for humoral immunity. And I want to thank everybody for listening and have a wonderful day.